phases: object modeling, dynamic modeling, and functional modeling. The three phases. So we are right now talking about object modeling. This is what object modeling we are talking about. So the object model describes the structure of the objects in a system. You have to follow certain steps for object-oriented design. So the steps for object-oriented design methodology. So right now we are talking about OOD, object-oriented design. So OOD methodology. What are the steps? You have to produce the object model, produce a dynamic model, produce a functional model, define the algorithm for major operations, and optimize and package. So these are the steps when you make a design of the object oriented system, right? So first you have to make a object model. Object model will have your class diagram, object diagram, and all that. Then you have to produce a dynamic model which will have your sequence diagram, collaboration diagram, deployment diagram, all that. And then you have to produce a functional model. Functional model will have your DFD, data flow diagram, right? Then you have to define the algorithm for the major operations, and then you have to optimize and you have to package. These are the steps which are there in object oriented design. So the first step for object oriented design is object modeling, right? This one. First you have to produce the object model. So before we go into details of object model, we should first know what is object modeling. So you can say that object modeling. So what is the definition of object modeling? Is it identifies the objects and classes in the problem domain and identifies the relationship between objects. So object modeling is identifying the objects and classes in the problem and also their relationship between the objects. So the goal of object model design is to capture those aspects or concepts of the underlying system that are important to represent the system in real world in the context of the problem to be solved. So in the object modeling process, we first have to identify objects, then structures, attributes, associations, and finally services. So this is the main thing in which object modeling, what we are doing. We have to find the classes, we have to find the objects, their structures, their attributes, their operations are need to be find out. Then we are talking about what is the association part. There are two types of association: aggregation and composition. Right. So what is aggregation? Aggregation represents a has a or a part of relationship. So aggregation is tightly coupled form of association, and aggregation depicts a complex object as an assembly of many object components, where these components are also objects. So you may characterize a house in terms of its roof, floors, foundation, walls, rooms, windows, etc. A room may in turn be composed of wall, ceiling, floor, windows, doors, as represented in figure 1. So if you see a house, so what does the house contain? A house has roofs, a house has uh, number of roofs, whatever you can say. So if you see here, this is the symbol of aggregation. Hollow diamond is a symbol of aggregation, right? So house, the roof is part of the house, or house has a roof. So has a or a part of relationship is known as aggregation. So house has roofs, and roofs can have doors, windows, walls. So this is also aggregation. And the roofs can be not be part of some house, they can be part of some other thing. So that is also a separate roof can also be there. But right now, so aggregation is part of, right, relationship, not fully dependent but part of relationship. So that is what they are talking about, right? So the decomposing of a complex object into component objects can be extended until the desired level of detail is reached in UML. So that is whole or part thing we are talking about. This is the whole and this is the part, right? So so this is what aggregation is. So aggregation is a concept that is used to express part of type of association between objects, and aggregate is conceptually an extended object viewed as a single unit by some operations, but it can actually be composed of multiple objects, right? So that is there. So aggregation, you can be asked a theory question, what is aggregation, and give an example of aggregation. So that for that you should see from here only, you can give an example. Aggregation is a special kind of association. This is a definition. Adding additional meaning in some situation. Two objects form an aggregate if a whole part relationship tightly connects them. If the two objects are typically viewed as independent objects, their relationship is usually considered an association. So Grady view suggests these tests to determine whether a relationship is an aggregation or not. Would you use the phrase part of to describe it? Are some operations on the whole automatically applied to its parts? Are some attributes values propagated from the whole to all or some parts? Is there an intrinsic asymmetry to the association where one object class is subordinate to the other? Then uh, if you have an aggregation, if your answer is yes to any of these questions, so if your answers to any of these questions is yes, then it is a aggregation, part of relationship. So aggregation is not the same as generalization. Now what is generalization? So generalization relates distinct classes to structures, the definition of a single object, superclass and subclass. So inheritance concept, superclass and subclass refer to the properties of one object, right? So a generalization define objects as an instance of a superclass and an instance of a subclass. It is composed of classes that describe an object, often referred to as kind of relationship. Aggregation relates objects instances, one object that is part of another, right? Aggregation hierarchies are composed of object occurrences that are part of an assembly object, so often called a part of a relationship. A complex object hierarchy can consist of both aggregations and generalizations, right? So here, if you see, a person is there, company is there, right? So and this is your aggregation which is applied. So person and company are have a relationship, and position is another thing. So this is a ternary relationship here. So person is working in a company. Zero or many persons are working in zero or many companies, and company has division and division has department. So has a relationship is a aggregation here, right? So now a stronger form of aggregation is called composition, which implies exclusive ownership of the part of classes by the whole class. Composition means part of the system may be created after a composite system is created. Remember that in such system, part will be explicitly removed before the destruction of the composite. Right? Fill diamond indicate here they have not shown fill diamond. The division will not be there if the company is not there, right? If the company is not there, no division or no department will be there. So this is a whole uh, uh, without this company, the division and department will not be there. So this kind of a relationship is a stronger aggregation, or which is known as composition, whole ownership, right? But when we were talking about the roof, house and roof, a roof of some other building can also be there. They can be separate roofs also, but and this house also has roofs. So this is not whole relationship. This is a part of relationship, right? So that is what they are talking about. And here this is a, without this company, the division and department are not there. So this is a commit wholly ownership kind of a thing. So that is known as composition. So this diamond should be a filled diamond. Filled means black color should be filled here. And hollow diamond is for aggregation, and filled diamond, here they have not filled the diamond, this should be black colored filled. So filled diamond is a composition. So that is what this means. So shows that a person works for a company. The company has many divisions which are part of the company, and each division has departments which are again part of the division. Right? That's why. Then what is abstract class? An abstract class is used to specify the required behaviors, operations, or methods of a class without providing their actual implementation. So abstract class is a class which doesn't have any method or operations, right? Without providing the implementation, right? It is a base class, but it doesn't have any implementation or anything inside the abstract class. So in other words, you can say that methods without implementation or body are part of abstract class. So you define a method inside the class, the declaration is there, but the body of the method is not there. That means no implementation is there. So an abstract object class has no occurrences. Objects of abstract classes are not created but have child categories containing actual occurrences. So what they are saying is abstract class objects are not created, but the abstract class child objects are created. Right. So a concrete class has actual occurrences of objects. If a class has at least one abstract method, it becomes very, by definition, an abstract class. So if you have an abstract method inside a class, so that class becomes an abstract class. Abstract method is a method which doesn't have a body because it must have a subclass to override the abstract method. So an abstract class must be subclass. You cannot instantiate it directly. That means you cannot create an object of the abstract class directly. So here you may ask one question, why are abstract class created? So the answer to this question is to organize many specific subclasses with a superclass that has no concrete use. So what we are doing is we are making many subclasses, specific subclasses under a superclass, right? But this superclass has no concrete use, right? To organize the subclasses, we are making a superclass. And an abstract class can still have methods that are called by the subclasses. You have to take this correct point into consideration in the case of abstract classes. So abstract class can still have methods. Other methods can be there apart from abstract method. It can have methods which can be that are called by the subclasses. Abstract method must be overridden in a subclass. So if you have a method called any method which is abstract in the abstract class, abstract method, so that you have to override in your child class, right? You cannot call it directly, so you have to override in the child class, right? Only a concrete class can appear at the bottom of a class hierarchy. That means the concrete class means the class with for which objects can be created. So this is your suppose this example they have given you. This shape class is your abstract class, and rectangle, polygon, and circle are the child classes of this shape class, and rectangle and polygon and circle are your concrete classes. They will appear at the bottom of a class hierarchy because for these classes the objects can be created, right? If you see here, the shape class has move method, resize method, draw method, right? So move and resize can be taken for rectangle also, polygon also, circle also. They can access that, they can inherit the methods. The draw method is the abstract method. This draw method, shape draw method, is the abstract method, which is overridden in rectangle also, overridden in polygon also, overridden in circle also. That means rectangle is drawn in a with length and breadth, polygon is drawn in a different way, circle is drawn with the radius and all that. So every shape has a different parameters to draw a shape. So that's why this draw method has been overwritten in the child class, right? So that is what this thing they are explaining, right? So the shape class is a natural superclass for shapes like rectangle, polygon, and circle. Every shape requires a draw method, but the method has not been provided with any meaning in the superclass shape, so we make it an abstract class. Right. Subclasses provide another implementation to the method as per their need. The subclass provide the implementation of their draw method since rectangle, polygon, circle can be drawn differently. Right. So abstract classes can appear in the real world and be created by modelers to promote the reuse of data and procedures in systems. They are used to relate concepts that are common to multiple classes. An abstract class can be used to model an abstract superclass to group classes that are associated with each other or aggregated together. An abstract class can define methods inherited by subclasses or define the procedures for an operation without defining a corresponding method. The abstract operation defines a pattern or an operation which each concrete subclass must define its implementation in its own way. So this they have defined you what is aggregation, what is composition, what is generalization, and what is abstract class. So these things are there. So a class inherits its parents. Attributes, operations, and relationships, right? Which of the following is not characteristics of an object? Action, I think. Which of the following is not characteristics of an abstract class? At least one abstract method. Methods may or may not have an implementation body. Subclass must implement the abstract methods of superclass. I think B is there. Methods may or may not have implementation body. Abstract method may not have implementation body. When abstract classes are to be used in a system, so whatever is given here, when you can use the abstract class, this is what, when you want to use an abstract class, so that is what you have to give here. Then they are talking about multiple inheritance. So we talked about inheritance, which is generalization. So inheritance allows a class to inherit features from parent class. Inheritance allows you to create a new class from one or more existing classes. So that means parent-child relationship, you inherit the properties of your parent. That is what inheritance is. So there are different types of inheritance. Inheritance gives several benefits such as reduce duplication and increase reusability by building on what you have already created. So if you have created something in one class, you don't have to again recode that code again. You just make the other class child class of the parent class, and you can access the code or reuse the code in the child class. So you are reducing duplication and increase reusability. Then organize the three classes of the system in the ways it may appear in real world situation in the problem. The other benefit is, as in the real world, whatever the situation is, you can organize that through inheritance in your program. So here what they are saying, person and employee. You can see that employee class is inherited from the person class. So a person is there and you are inheriting employee class from the person class. This is single inheritance, one parent, one child, right? You also have multiple inheritance. So what is multiple inheritance? In multiple inheritance, you are accessing from two parents. Like here, vehicle class, you have cargo vehicle, passenger vehicle. So this is single inheritance because cargo vehicle has one parent, passenger vehicle has one parent vehicle. But when you see here, the this van is a part of cargo vehicle also. This van is part of passenger vehicle also. So this is known as multiple inheritance. When one child is accessing from two or more parents, two parents, cargo and passenger, two parents are there, not one parent is there, two parents are there, then it is multiple inheritance. And then this is again single inheritance because full size van and mini van, this is single inheritance only. When you are inheriting from two parents, that is known as multiple inheritance. So multiple inheritance extends this concept to allow a class to have more than one parent class and inherit features from all parents. Thus, information may be mixed from multiple sources. It is a more complex form of generalization. Multiple inheritance does not restrict a class hierarchy to a tree structure as you will find in single inheritance. So multiple inheritance provides greater modeling power for defining classes and enhances opportunities for reuse. So if you are accessing from two or more parents, so you can have methods or properties from this also, methods and properties from this also, right? More reusability will be there. So using multiple inheritance, object models can more closely reflect the structure and function of the real world. The disadvantage of such models is that they become more complicated to understand and implement. For example of multiple inheritance, in this example, van classes have inherited properties from class cargo vehicle and class passenger vehicle. The advantage of if you have more parents and more complication will be there, so that will be a difficult situation. Otherwise, it is the advantage is that advantage of multiple inheritance, it facilitates the reuse of existing classes much better than in single inheritance. So if the properties of two existing classes have to be inherited, single inheritance, multiple inheritance is available, right? So you can inherit from two or more classes, that is multiple inheritance. Then here, the use of delegation as an implementation mechanism by which an object can forward an operation to another object for execution. Working with multiple inheritance can be difficult in implementation when one single inheritance is supported. But analysis and design models can be restructured to provide a usable model. The recommended technique for restructuring includes delegation using an aggregation of roles. A superclass with multiple independent generalizations can be recast as an aggregate in which each component replaces a generalization. For this, you have to inherit the most important class and delegate the rest. Here, a join class is made a subclass of its most important superclass. Nested generalization, factor one generalization first, then the other, multiplying out all possible combinations. So they are saying if you have multiple you have multiple inheritance, so implementing a mechanism where multiple inheritance, you have single inheritance also, multiple inheritance also, and implementing single inheritance with multiple inheritance will be a difficult situation, but how you handle that you have to see. So the best workout they are saying is Rambhav suggests issues to consider when selecting the best workaround. If the subclass has several superclasses, if your subclass have several superclasses, many, that means many parents, all of equal importance, it may be best to use delegation and preserve symmetry in the model. If one superclass seems to dominate and others are less important, implementing multiple inheritance via single inheritance and delegation may be best idea. Right? If the number of combination is small, consider nested generalization, otherwise avoid it. If one superclass has significantly more features than the other superclasses, or one superclass seems to have a performance bottleneck, preserve inheritance through this path. If nested generalization is chosen, factor is the most critical criterion first, then the next important, most important, etc. Try to avoid nested generalization if large quantities of code must be duplicated. Consider the importance of maintaining strict identity, only nested generalization preserve this. So they are saying you have to use generalization or multiple inheritance with ease, with the you have to understand that first and then use multiple inheritance, because if you have lot of multiple inheritance, it will complicate your code. So that rather than that, you should either use aggregation or you should either use single inheritance rather than multiple inheritance. That is what they are trying to tell you. Then what is generalization and what is specialization? So generalization means extracting common properties from a collection of classes and placing them higher in the inheritance hierarchy in a superclass. So generalization and specialization are the reverse of each other. An object type hierarchy that model generalization and specialization represents the most general concept at the top of an object type hierarchy as a parent and more specific object types as children. So if you see from the parent point of view, it will be generalization. Employee has two types of employees are there: salaried worker and hourly worker. And if you see from a specialized form or a specified thing, that salaried worker is an employee or hourly worker is an employee, from the bottom to top, if you see, it is specialization. From top to bottom, if you see, it is generalization. So when generalizing, as in the real world, care should be taken so that the property makes sense for every single subclass of the superclass. If this is not the case, the property must not be generalized. Right? So, so this is generalization hierarchy of employee class they have created. There are two types of employees: salaried worker and hourly worker. So specialization involves the definition of a new class which inherits all the characteristics of a higher class and adds some new ones in a subclass, so that the derived class has some additional features compared to the superclass. So in this, suppose I am talking about this salaried worker, the child class, which is inheriting all the properties of the employee class, and it also has its own properties, salaried worker. Right? That is what specialization is telling you. Right? In other words, specialization is a top-down activity that refines the abstract class into more concrete class, and generalization is a bottom-up activity that abstracts certain principles from existing classes to find more abstract class. Right. So we often organize information in the real world as generalization or specialization hierarchies. The creation of a particular class involves a first or second activity, depends on the stage and state of analysis, whether the initial classes suggested are very general or very particular. Right. So they have not given an example here. This is the example they are given. So, for instance, an employee may either be a salaried or a hourly worker. A salaried worker can be a manager. Also, in turn, that employee can be executive department manager or a unit supervisor. The employee classification is most general. The salaried worker is more specific, and also the unit supervisor is more specific. Of course, you might not model the world exactly like this for all organizations, but you will get the idea. So unit supervisor is a subtype of salaried worker, which is a subtype of the employee. So employee is the highest level supertype, and the salaried worker is the supertype of executive, department manager, unit supervisor. So an object type could have several layers of subtypes and subtypes of subtypes. The generalization or specialization hierarchies help describe application system and indicate where inheritance should be implemented in object-oriented programming language. So that is what generalization and specialization is. So, what are the rules of inheritance? So, Rambach proposed the following semantic rules for inheritance. All query operations, ones that read but do not change attribute values, are inherited by all subclasses, right? All update operations, one that change attribute values, are inherited across all extensions. Update operations that change constraint attributes or associations are blocked across the restriction. Operations may not be overridden to make them behave differently from inherited operations in their externally visible manifestations. All methods that implement an operation must have the same protocol. Inherited operations can be defined by adding additional behavior. So, in this, you should know what is generalization, what is specialization. You should know the definition, and you should give an example of the same. So that is what polymorphism can be described as dash. Polymorphism can be described as I think generalization, because hiding many different implementation behind one interface is not polymorphism, right? It is similar to inheritance but little bit different. What phrase best represent a generalization relationship? Is a kind of is a generalization relationship. All update operation inheritance are updated across all extensions. I think across all extensions. Hmm. Is generalization specialization reverse of each other? Why? So these questions to these answers will be at the next in the end of the unit, so you can see them. Right now they are talking about database, rdbms, relational database management system, which uses metadata. Metadata means data about data. So metadata can be defined as such set of data which describe other data. For example, when you have to describe an object, you need to have a description of the class from which the object is instantiated. So here the data you are going to describe class will be treated as metadata. So your data is your object and the object is part of a class. So you have to define the class. So that is your metadata. So you may say that every real world thing may have metadata because every real world thing has a description for them. Let us take the example of an academic institution and its directors. You can store that department A is having X as its director and department B is having Y as its director, and so on. Now you have concrete information to keep in metadata that every department in the institute has a director, right? So this is what metadata is. Now data about data. So now key. What is a key? To identify an object, attribute, or combination of attribute is used. This attribute or combination of attribute is called a key, right? So if you know about database, so you know that in a database you create tables, right? So tables are collection of rows and column. Your rows are your tuple. Your rows are your tuples or record, and your columns are your fields or attributes. Attribute name, right? So the key is a combination of attributes which are there. So you have to decide which is the main attribute you have to take, and according to that you have to arrange your data. Like one of the key is the primary key. So in a table, a primary key is an attribute or a combination of attributes that uniquely identifies an object instance and corresponds to the identifier of an actual object. For example, customer number would usually be the primary key for customer object instances. To identify a customer, his customer number will be his primary key. So two or more attributes in combination sometimes may be used uniquely identify an object instance. For example, combination of last name, first name, and middle initial might be used to identify customer or employee object instance. Here you can say that sometimes more than one attribute gives a better chance of identifying an object. For example, last name alone would not suffice because many people might have the same last name. The first name would help, but there is a still problem with uniqueness. So all three parts of the name are better still. Although a system generated customer or employee number is best used as an identifier, absolute uniqueness is desired. So primary keys that are not actually selected and used as primary key are called candidate keys. So primary key is a key which uniquely identifies elements in a table, right? Or there may be some other keys also which can act as primary key, but we select one. The other keys which can also act as primary key, and we have not selected that as primary key, are known as candidate keys, right? What is a secondary key? A secondary key is an attribute or combination of attributes that may not uniquely identify an object instance but can describe a set of object instances that share some common characteristics. So an attribute customer type might be used as a secondary key to group customers as internal to the business organization, subsidiaries or divisions, or external to it. Many customers could be typed as internal or internal or external at the same time, but the secondary key is useful to identify customers for pricing and customer service reasons. So those keys which are not which may not uniquely identify the object, those are known as secondary keys, right? So like customer type is a secondary key, right? So that is what are there. The primary key and secondary key they have explained here, the key. Then they are talking about integrity constraint in database. So what is referential integrity? So referential integrity is you have two tables, uh, employee and department, right? So if we create a combined table of employee and department, we have not created a separate table. So what will happen? There may be duplicate values in the table. So we divide the table into two. One is an employee table, the other is a department table. Employee table has primary key as employee ID. Department table has primary key as department ID, right? So to connect both the tables, how do we connect them? We will keep a department ID in the primary key of department table. Department ID is kept in employee table also. Department ID is kept in employee table also to connect the two tables. So if we want to know that employee 101 works in which department, so we will see that the department number for that employee is 102 or 02, whatever department number will be there. So 101 employee is working in 02 department, and it is connected to the table, department table with so in employee table you have department ID, in department table you have department ID. With that link you are connected and you can see what is the name of the department. So that is known as referential integrity, foreign key. So in department table, department ID is primary key, and in employee table, if you have kept the department ID, in employee table, department ID is the foreign key. So constraints on association should be examined for referential integrity implications in the database model. Ask when referential integrity rule should be enforced. When you are modeling object instances over time, you may need to introduce extra object classes to capture situations where attribute value can change over time. For instance, if you need to keep an audit trail of all changes to an order or invoice. You could add a date and time attribute to the order or invoice objects to allow for storage of historical record of their instances. So referential integrity is important there, right? So I've already told you the example. Then there are certain rules they are talking about, insert rules. So these rules determine the conditions under which a dependent class may be inserted, and they deal with restrictions that parent class impose upon such insertions. The rules can be classified into 6 types: dependent, automatic, nullified, default, customized, no effect. Right. So dependent is permit insertion of child class instance only when the matching parent class instance already exists. Automatic means always in permit insertion of a child class instance. If the parent class instance does not exist, create one. Nullify always permit insertion of the child class instance. Default always permit insertion of a child class instance, and customize allow child class instance insertion only if certain validity constraints are met. And no effect always permit insertion of child class instance. No matching parent classes instance may or may not exist. No validity checking is performed. So there are certain rules. You can have dependent rule also, automatic rule also, nullify, default, or customize, or no effect to add a child to a parent, or a child may not have a parent. Such kind of rules you can do. Then you have domain integrity. These integrity rules define constraints of valid values that attribute can assume. So domain integrity will depend on the data type. So valid values. Suppose date of birth, you have set date, right? Date and time, or your date, you have set the data type as date. So if you are putting some separate numbers, not the date format, then the domain integrity will not let you put the date in the database, right? Then the length of the data, if there is a constraint on the length of the data that you can put only 8 characters, or you can, like in a password, or you can put this much characters, that is also uh, you can put allowable value ranges. So how much value can be allowed from this to this, value uniqueness, right? If you cannot duplicate have same value in another row also, whether a value can be null or not. So if you are saying null or not null, so depending on that, you may allow in the domain that this attribute may allow null value or may not allow null value. According to that, you can see. So these integrity rules define constraints on valid values that attributes can assume. A domain is set of valid values for a given attribute, a set of logical or conceptual values from which one or more attributes can draw their values. For example, India state codes might constitute the domain of attributes for employee state codes, customer state codes, and supplier state codes. Something like that, right? So the domain describes a valid set of values for an attribute, so that domain definitions can help you determine whether certain data manipulation operations make sense. So they are saying there are two ways to define domains. One way to define domain, that define the domain first, and then to associate each attribute to your logical data model with predefined domain. So you can do that. Then domain definition are important because they verify that attribute values make business sense, determine whether two attribute occurrences of the same value really represent the same real world value or not, determine whether various data manipulation operations makes business sense. So that is there. Like here they are saying typical domain values: data type, data length, right? Allowable data values, data value constraints, uniqueness, null values, default value. All these you can set. You can set the data type, you can set the data length, you can set the data allowable data range, you can set the constraint that if certain uh, these are the allowable numbers, or this is what you can put, characters only you can put, or numbers only you can put, unique numbers can be put, null values can be put or not, default value, whatever. If you don't put the value, then what default value will be automatically put, right? Then triggering operation integrity rules. So triggering operation integrity rule govern insert, delete, update, and retrieval validity. These rules involve the effects of operations on other classes or other attributes within the class, including domains, insert or delete, and other attributes within a class, including domains, and insert or delete and other domain business rules. So the different integrity rules which are applied for triggering operations like insert, delete, update, and retrieval. So, triggering operation constraints involve attributes across multiple classes or instances, two or more attributes within a class, one attribute or class, and an external parameter. So, example of triggering constraint include an employee may only save up to 3 weeks of time off. A customer may not exceed a predetermined credit limit. All customer invoices must include at least one line items. Order days must be current or future dates. So, triggering operation have two components: the event or condition that causes an operation to execute, and the action set in motion by the event or condition. Right? So these are the triggering events they are talking about. Now they are talking about an object model. So in this section, let us examine sales order system object model. In this sales order system example, there are three methods of payment: cash, credit card, or check. The attribute amount is common to all three payment methods. However, they have their own individual behaviors. So figure 6.7 shows the object model where the directional association, the diagram indicates the direction of navigation from one class to the other. So if you say order, customer, payment, and what is that? Right. So here in the order, order is connected to the customer. One customer can or zero or more. He can order zero or more, right? And this is part of the order. I don't know what is this bill or what is this. And then order is connected to the payment, and payment has amount as the attribute. And you can do payment in these forms: check, credit card, cash. So payment can be done in check, credit card, and cash. And this is connected to the product for information, which can be put in the order. This kind of a thing they have created object model, right? So they have given you check progress question and answers. You can read them. So this was generally about topics where if you are asked questions about what is generalization, what is specialization, what is metadata and keys, what is integrity constraints, what is multiple inheritance, what is aggregation, what is abstract class. So you may ask or aggregation or composition. So you may be asked theory questions on them. So this is about all those topics which they have covered, right? Then the next one is dynamic modeling. So this was object modeling. So we talked about three kinds of models, right? Object model, and then comes dynamic model, and then function. So we have done object model. Now we are talking about dynamic model. So in the dynamic model, again, we are talking about the state and state diagram, state chart diagram, concurrency. So I'm not reading the whole thing. We again state chart diagram depends on the change of state according to some event. So the dynamic model shows the time dependent behavior of the system and the objects in it. So events can be defined as something that happen at a point of time, right? So that is what dynamic model is. So again, they are defining what is an event. Like a mouse click is an event, applying a brake is an event, right? So again, they are talking about that. Then state and state diagram. State is a condition during the life of an object, and actions are atomic and non-iterable. Whatever actions are taken during the lifetime of its state changes according to that action. So here a state is shown as a rectangle with rounded corners, right? Like this. This is a state. This is your initial state. This is next state. This is next state, and this is the final state, right? So we have seen that. Like here, they are giving you an example of login, state chart diagram of login to to any system. So here, the initial state is this. Then you go to getting pin, right? Then you submit it to the validating. state, and the validation is done. Do or validate pin number. If your validation is correct, validation is valid, you go to the stop or the final state. Your transaction starts, and if it is not valid, it is rejected and then goes to the final state. You will display an error and go to the final state. So something like that. So logging in can be factored into four non-overlapping states: getting pin, validating, and rejecting. 1, 2, 3. Right. So state machine is a graph of states and transitions that describe the response of an object of a given class to the receipt of outside stimuli. A state machine is attached to a class or a method. So state chart diagram represent a state machine. State symbols represent the states, and transitions are represented by arrows connected to state symbols. So they are talking about that. Then they are talking about what are the different elements of a state diagram. You have an initial state, you have a state, you have event or action. There is a history state also if you want to show. So a flow may require that object go into a trance or wait state, and on the occurrence of a certain event, go back to the state it was when it went into a wait state, it last active state. So this is a wait state, H enclosed within a circle. Right, then you go back to from wait state to the active state, then you have to put this H. Then event and action will be the arrow, where then you can also have a signal, and this is your final state, dark circle or outside hollow circle. Right. So they are talking about advanced concept in dynamic modeling. So entry and exit actions are there. So here they like typing password, entry or set echo invisible, and exit or set echo normal, character or handle character display. So these kinds of things they are talking about. We are not. You can put a guard condition also. A condition can trigger an event or action to change the state of the machine. What is concurrency? You should know. So in a dynamic model, some systems are described as a set of concurrent objects, each with its own state and state diagram. Concurrent means working simultaneously, independent states working simultaneously. Right. So an expansion of a state into concurrent substate is shown by tiling the graphic region of the state using dashed lines to divide it into subregions. Each subregion is a concurrent state substate. Each subregion may have optional name and must contain a nested state diagram with its disjoint state. So we have seen in the example when we had shown the state diagram, you have the main state diagram, and inside that there is another part of the state diagram, that is the substates. So that kind of a thing you can show in concurrency. So you can say that a state can be decomposed using and relationship into concurrent substates, or using or relationship into mutually exclusive disjoint substates. So given state may only be defined in one of the two ways. Its substates may be defined in the same way or the other way. Right. So here, so this is a sequential substate where you are dialing a number, and then partial dial is there. Enter the member. The digits are entered, and when your number is dialed, you go to the final state. Something like that they have shown. So here they are making the dynamic model. Right. So this is a state transition diagram for digital watch. So you have a display. You have set hours, set minutes, set seconds. These are the states. So here there should be a initial state, and here there should be a final state, something like that. So in the display, do or display current time. Display will be displaying the current time. So you will select the mode button, and you will go to the set hours state, and it will display the hours. You can press the button to change the hours. It will go in this state only. If you want to change the hours, you will go to this state only after pressing the button. And if you press the mode button again, you go to the set minutes, and it will display the minutes. If you press the button of the change minute, and it will change the minutes, and the minutes are set in this state only. And then if you again press the mode button, it will go to set seconds, and then you can set the seconds also after pressing the button, change second button. So it will remain at set second, and then at finally it will display the current time. Yes, right, and you can go to the final state there also. So this is how digital watch they have shown. So this was the same thing they have shown here. Now here they are showing state diagram for a mobile. So this is dial digit, this is timeout, and after 20 seconds, if you are not dialing anything or pressing the button, so timeout will be there. So it will play a message, and if you have dialed the digits, it will go to dialing, right? After dialing, if your digits are correct, and it goes to the connecting state and then to the ringing state, and it will ring and you start talk. After ringing the ringtone, the person picks up the phone and you start talking. If at dialing, after dialing after 20 seconds, if you are dialing and you have not dialed the number, again it will go up. Some of the numbers you have dialed not the full, so after 20 seconds it will go to timeout. Otherwise, if you have dialed a invalid number, if you have put a invalid number, it will go to invalid and play a message. And when you connect to the dial number, if your number is right and you are connecting, and your number is busy, right, it is not ringing, then it will show a busy message, busy state. So this kind of a thing they have shown you. So you can go through all these questions which they have given you right at the end of the chapter. So this is your state chart diagram which they have shown you, the dynamic model in unit 7, because we have read it earlier also, so the same thing is there. Then in this unit, in the next one, we go from dynamic to the functional model. So in the functional model, as all of you in the first semester must have done software engineering, so you do DFDs there also. So same thing is in functional modeling. So functional model basically define data flow, right? So the functional model is a graphical representation of the object-oriented analysis model and focuses on various processes to be performed on input data to obtain the desired output. Here, the system is viewed as a black box that accepts input, transforms them by applying various processes or functions, and then produces the output. So, functional model does not show how the transformation occur when they are performed and why there is a need to do the calculation, but they show it is a kind of a black box which shows what are the processes and what are the functions and what will be the output. The input to the system can be numbers typed by an operator or control signal produced by a sensor, some big data files received over a network. The process that work on inputs may be performing some mathematical logical calculations or applying some algorithm to generate one or more outputs in the form of some numerical value or some control signal that may be used to drive other devices. So we use DFDs, data flow diagrams, to explain the flow of data from input to output, right? So we can also say that by using functional model, the software requirement specification document is converted to DFD, right? Data flow model. So what is DFD? Data flow diagram is a simple graphical technique that represents an entire software system in terms of input fed to it, processing applied on these input, and output produced by the system, and various data stores and used internally to store the data results. So basically, data flow diagram shows you what are the inputs applied, what process, some processing is done, and what output you get, and there are internal storage or data stores there. So this is what you have to show in DFD, how data is flowing in the system. The focus is on flow of data input into a system by a source, transformed by the application of various processes, and then sent to destination as output. This is what it is. So if you have to write the definition, this is what the definition of DFD is there. What are the features of DFD are? The features of DFD can be explained. That means the features are the symbols. Circle or bubbles are used for representing the processes. Arrows are used for connecting the processes. Rectangle is used for the entities or the actors or the source, which is there. And two parallel lines or rounded rectangle, it is used to represent a data store. Parallel lines like this is a data store. This is entity. This is process. This is output like this. and data flow like this, and data store like this. A rectangle with right top corner chopped off like this represent the output of the form of a hard copy. These are the symbols you use, right? So process, they have given you a circle, but you can draw an oval. Rather than a circle, you can draw an oval also. So if you go to a word file, right, if you go to draw, not draw, insert, sorry, in insert, if you go to shapes, you have flowchart shapes also here. So this will be your flowchart. Just hold on for a second. Yes. So you can have a process in the shape of an oval rather than like this. This shape is you can say you can take it as an oval rather than a rounded circle, right? So this will be your process. Like here, the process is calculate sum. So you are passing A, B, and C variables, and you are calculating the sum, and the sum output is given here. The sum. This is a process, right? Same way here, you are performing the division. You are passing the dividend and the divisor, and the quotient and remainder are coming as the output, right? So this thing, and when if you are connecting a entity, user is the entity and log calculator is the process. So user is putting a number to the log calculator, and log calculator calculating and giving the log number to the user, like that, right? So data flows are the arrows which you are showing, right, where the arrows are going. So that is there, that is data flow. Then synchronous versus asynchronous data flow. So the DFD in figure 8.7 shows the three data flows. The data item integer flowing into real number process like this. The data item named integer flowing from read number process to find modulus process. Data item named modulus number flowing out from the process modulus. So like this. These are your data flows. In order to explain this concept, we have shown a part of a software system that reads a number and then finds its modulus. In case of synchronous data flow, the output produced by the process read number is immediately used by the process find modulus, a data flow arrow that directly connects both processes. Hence, the three-dog operation of both the processes is the same. Right. In case of asynchronous data flow, as shown in figure 8.8, there sits a data source between the two processes here, this, right? So the first process produces the data stored in the data source. Later on, another process can use this. As we can see that two processes are independent of each other. This type of data flow is called asynchronous. So what is happening? You are passing the data item, the read number will read the data and store it in data this number data store. And when the find modulus process will take the number from the number data store and then find the modulus and print it. So this type of data flow is called asynchronous. If you are passing directly to the process, is known as synchronous. If you are passing through a data store, it is known as asynchronous. Right, then actors are represented as a rectangle or entities, you can say. An actor is an external entity that produces the data. So what are the actors here? Like employee and accountant are the actors. So employee details are fetched from the payroll processing, and the salary information will be passed to the employee, and the payroll processing will get the salary information from the accountant, like that, right? Data store is simply a database, like parallel lines, and in between that you are writing library database. So any book detail or has to be passed from the data store. So data store is a passive object that represents a repository of data in the software system and is represented using two parallel lines. A data store symbol represents either a data structure or physical file residing on a disk, right? So like finding average. So here sales database is there. So the finding average process is taking the sales information from the sales database and then calculating the average. Then output symbols is chopped off rectangle, top right corner chopped off. You can also have constraint. A constraint represents the relationship between two different objects at the same time, or between different values of the same object at different times. So constraints mean the conditions or limitations required to be fulfilled over a period of time. Right. So all the models of object-oriented analysis can have constraints in them as explained below. Object modeling, here constraints show the relationship between objects. In this type modeling, constraints represent the relationship between the different values that an object may have at different times. Dynamic modeling, here the constraints define the relationship between the states and events of different objects. And functional modeling, in this the constraints define the limitations on the transformations and computations that can be done on objects. Right. So this they have given you. Now, so this, like here they are this is a constraint in DFD. This is how you write a constraint in curly brackets. A string written in braces in curly brackets is a constraint. So department sales, what sales department you have made this. So this figure 8.12 shows a DFD in which, depending on the department of an employee, either he is given an incentive or an increment. As it is visible, if a department is sales, then the incentive is calculated, and if the department is HR, then increment is calculated. So here, if you see here, department sales, employee database is there. So calculate incentive, calculate increment. So increment is for HR. So here they have given wrongly. This department should be HR here, and this is sales. So if the department is sales, the calculate incentive will be there, and if the department is HR, calculate increment will be there. The process calculate increment will be there. So this is how constraints are put in DFD according to a condition. Then control flow signal is generated by a process so as to inform other process to start or stop its processing. This is typically a Boolean value passed to another process on the basis of which other process divides its course of action is denoted by a dotted line. An example of control flow is shown. The customer enters the password in a net banking website which is verified. Only after that he can transfer money to somebody else's account. So like this. So customer is there. Customer enters the password to the system verify process. The verify process checks the password from the bank database and verifies it. Right. So if the password is correct, then the dotted line is there. So this is control flow. Right, dotted line. So password is correct, then the transfer amount, the customer enters the transfer amount, and the confirmation is sent to the customer for transferring the amount. That kind of a thing, right? If the password is not correct, then he won't be able to transfer the amount. So design flows in DFD. So there are certain limitations of the DFD which may lead to a few design flaws. The most disturbing limitation is that with DFD we cannot visualize the complete picture of the software system, and hence some of the essential physical entities are left out. Also, at times it can be tough to conceptualize an object-oriented structure in a hierarchical format. So there are different categories of design flaws. Flaws committed by beginners. The context diagram must have just one bubble that represents the complete software system at abstract level and has arrows of input and output interaction corresponding to data flows with the world. Many designers draw more than one bubble in the context diagram, which must be avoided. So what they are saying is, what is the context diagram? The first diagram, or the zero level DFD. The first diagram, zero level DFD, is known as context diagram. The context diagram should only have one bubble. That is one process. Right, there should not be more than one bubble or more than one process. Only one process should be there in the context diagram. This is one flaw. Then external entities are drawn only in the context diagram. That is, your in the context diagram only you draw, or the zero level DFD only you draw, and the entities, customer, whatever the entities are there. However, many designers represent the external entities at all level of DFD, which is not correct. Each process or bubble should be decomposed into between 3 to 7 bubbles, but sometimes designers do not follow this principle. Different levels of DFD must be balanced. Balancing of DFD means that the DFD flow into or out of a process symbol must match the flow at the next higher level of the DFD. So you should decide each process of bubble should be decomposed. That means each process should be decomposed in 3 to 7 bubbles only. That is what they are telling. Then representing control information in a DFD, one must clearly understand that DFD is not a flowchart. DFD cannot capture the following important features: when, why, and how. So when as the time dependent behavior of a system cannot be shown in DFD, why DFD cannot specify why the value of an object has changed, and how DFDs cannot mention the frequency of transformations done in an object, and if bubble X invokes either the bubble Y or bubble Z depending upon some condition, we need only to represent the data that flows between the bubble X, Y, or bubble X and Z, and not the conditions depending on which the two modules invoke. So mistakes arising out of poor diagrammatic approach, black holes, miracles, and gray holes. Such design flaws occur when outputs from a process do not match its input. A few examples of this design flaw are: black hole is if a processing step has just input flows but no output flow. And miracle is if a processing step has just output flows but no input flows. And gray hole is, as the name suggests, that it is confusing situation. Such a situation may arise when a processing step has outputs that are greater than the sum of its input. Example, its input could not produce the output show. So illegal data flows with data store. It is very important to realize that data store cannot be connected to bubbles using data arrows. A data store can never be connected to another data store or to an external entity. These are the mistakes which you do during designing of the DFD. So these you should avoid. So that's what they are talking about. So a sample functional model example DFD up to third level they are talking about. They are making a DFD. So every process must have a meaningful name which is unique and a unique number as its identifier. So every process you should give a name. Level 0 DFD, also called a context diagram. The first DFD must have just one process. Every data flow arrow must be named. A bubble should be decomposed into minimum of 3 and a maximum of 7 bubbles in further level. Hence, each TFD can have no more than 7 processes. A process can be connected only with another process, external entity, and data store. No two external entities can be connected directly with each other. No loop is allowed in a DFD. There should be logical consistency in all levels of DFD. The data flow of DFD should be easy to understand, and we should try to use arrow directions to depict the order of events for explaining the order of occurrence of the event. Our flowchart should be used. The numbering of the bubble is to be done very carefully. Each bubble is given a unique identification number. The bubble is in the context diagram, that is level 0 is given 0 number. Bubble in level 1 are numbered like 0.1, 0.2, 0.3 and so on. Bubble in level 2 that are formed are factoring or decomposing of each bubble of level 1. Say 0.1 of level 1 is factored its children as numbered as 0.1.1, 0.1.2 like that. Right. So a complete working example of DFD up to 3 level has been explained here. In order to represent the DFD of a system, first of all, 0 level DFD or context level DFD is drawn. It represents the complete software system. So they are giving you an example of functional model for online shopping system. So we have taken an example of DFD up to 3 level for a website for online shopping system for buying products of various categories: apparel, food, beverages, electronics, etc. There are two types of users, also called actors, who interact with the online shopping system. These are the administrator and the customer. So there are two entities. The administrator is the sole in charge of the website and is responsible for all features and facilities offered by the site. So first we will draw the level 0 or the context level DFD. So only login request and response for customer administration are depicted in this. The name of the process is online shopping system. So only one process will be there, online shopping system. The contact, so at there are two actors, administrator and customer. Administrator puts the admin details and get the response accordingly, and online shopping system, the customer puts his details and gets the response accordingly. This is a context level diagram. Then level 1 DFD if we make, so the context diagram is further, now it is further this context level diagram will be further decomposed into a hierarchical way to explain the system entire working. This is done by converting the level 0 bubble into 3 to 7 bubbles, which generally have labels denoting the functionality using verbs. So this produces level 1 DFD. Since there are many functions pertaining to the customer side and administrator side, level 1 DFD for both is shown. So from the customer side, level 1 will be shown, administrator side, level 1 will also be shown, they are saying. So level 1 DFD from the customer side, the customer can interact with online shopping system in one or more of the following ways. He can do registration, customer login, manage account, purchase item, make payment and return item. So these are the further division of the processes from the customer side. The customer is there, register, login, manage account, purchase account, make payment and return item are the processes which have been further divided. So this register customer database is connected to this register, login is connected to this database, manage account is connected to the customer database. Then purchase item is connected to the item or order database. Make payment is connected to credit card company database, and return item to the order database. You can connect this return item to this. You do not have to write to twice. You can connect it to here also. So this is how. So customer can register and get a response. Customer can log in. Customer can manage account. Customer can purchase, make payment, and return an item. Right? So this is your level 1 DFD, right? When you go to level 1 DFD of administrator side now, from the administrator side, what all he can do, he can admin login, he can manage category, manage item, manage order, manage report. So he from the administrator point of view, you have admin login, manage category, manage item, manage order, and manage report. And it is connected to the different administrator database, category database, item database, order database. And here it is user database, or all the databases you can connect to for getting the reports. So this is from the administrator point of view. Now we go to the level 2 DFD. So level 2 DFD, each of the bubbles of level 1 DFD may be decomposed into 3 or 7 bubbles so that the function can be explained at atomic level. So suppose customer side, they are explaining the manage account, right? So from the customer side, they are further refining the manage account. You can refine the register also, login also. They are refining the manage account process. So you can refine that in the second level DFD. So manage account, they have refined. The customer credentials are coming. You can view the account. You can change the password in manage account, or you can edit the profile. So in view account, right, you get the customer credentials from you request from the customer database to display the complete login, view the account information, and then you put the username to edit. You can take the username from the view account, and you can edit the profile, modify the profile will be modified in the database, and a confirmation will be sent. And in the view account, you can change the password also if you want. Just use your username, and you can change the password, update the password, and a reply will be sent. So this is manage account they have explained. You can also explain customer side purchase item also, level 2. So in the purchase, search items, search offers, manage cart, item database, and order database is there. So the customer credentials are taken, and then he searches the item from the item database, and then it goes to the search offers if there are from the item database, and then the item is added to the manage cart, and the order is updated accordingly. Right, then make payment is also there from the customer side. You have payment gateway, right, and you have issue order to administration and cancel order. So the customer credentials is taken, then payment gateway process is there, and it connects to the credit card database for credit card details, and confirmation is sent. And if the payment is successful, order is issued to the administrator, and order database is updated. And if the payment is cancelled or the request is cancelled, the cancel order request is sent to the order database, and according response is done. So, right, from the administrator point of view also, second level DFD is made. Again, manage account. So in the manage category, sorry, they are further defining the manage category. So add category, delete category, update category, view category. So administrator credentials, administrator can add a category. So from the item database, he can get the item details and confirm of addition, right? And he can add a new category to the category database, right? He can delete a category, he can update a category, or he can view the categories, something like that. Then manage items also, they have done add item, delete item, update item, view item. The administrator can do that. That is also second level DFD. Manage order also, he can do acknowledge order, view order, cancel or review order, and dispatch order to the order database. That is there. Then manage report is also there. Generate report, user reports, generate delivery report, generate payment report, generate supplier report. So all these reports also, the administrator, they are further refined. Then manage cart from the third level DFD, they have same manage cart. So in the manage cart, add item, view cart, edit cart, checkout from the customer point of view. Administrator dispatch order, they have done. Then contact supplier, contact delivery agent, manage return. So these are the things. So this is how they have shown your three level DFD, right? Then functional versus object versus dynamic model. So if you are asked the question, what is the difference between all the three? Object modeling technique consists of three models: object model, dynamic model, functional model. Object model, the purpose of this model is to show the static aspect of the software system, including depicting the attribute and operation that an entity can perform. That is, here the focus is on how an object can be implemented and what operations an object is capable of performing. And diagrams of the object model are object diagram, class diagram. Dynamic model, the purpose is to show the control aspect as well as the temporal and behavioral nature of the system, software system. The sequencing of operations is shown in the dynamic model. The focus is on when the operations are done in response to an external stimuli. And the diagrams which are there: state transition diagram, sequence diagram, collaboration diagram, right? Then functional model, this model is used to depict the functional aspect by showing various processes that include many sub-processes within them, along with various transformations applied to data as it moves in the system. This model focuses on what the operations do in terms of transformation on objects, and we use data flow diagram to show a collaboration between. So DFDs are used for in functional diagram. So this is what they have given, the different definitions. Now they are saying relation of functional model to object model. So in the functional model, we use four components that have one-to-one correspondence with components of object model: processes, actors, data store, data flow. So processes are the functions or methods that are implemented in the objects in object model. Actors correspond to objects of object model. Data store, these are nothing but the objects of the object model or the attributes of the objects. And data flow that occur as a result of operations performed on an object is shown in object model. And what is the relation of functional model to dynamic model? In the functional model, we can specify how the operations are performed and which arguments were required for those operations, whereas the dynamic model depicts the timing of an operation. So dynamic model specifies when it acts on an active object only, that is on an actor of functional model. The dynamic model does not mention anything related to data store as it is a passive object. The data store responds only to the updates and queries that do in the functional model only. So this is what they have given you in this unit, the DFD and the details about dynamic object and functional model, right? Any doubts in this? Any doubts, class? Now, the next units, next blocks are block 3 and block 4, which we'll be doing in the next classes. The next Saturday, Sunday, we have classes, then we will be doing. So we will be talking about the system design. So we'll be talking about designing of the system and all that in the next blocks. So is there any doubt, whatever we have seen? The different diagrams you have seen, and DFD you have seen. Any doubts?
No, ma'am.
All of you have started working on your assignments.
Yes, ma'am.
Any doubts in the assignment?
No, ma'am.
So we'll meet in the next class. So next are your two theory classes are left for your next class, and then we will start with the practical sessions. Right?
Yes, ma'am. Okay, ma'am.
Any doubts, anybody? Everybody has put their attendance in the chat box?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.